So I'm trying to take advantage of the snow day and get a couple of sets of notes knocked out, but I have a feeling it'll just be one set, but it's going to be two videos, so that's good because I got two classes that I'm doing this for. For you guys, we are looking at the graphs of equations in two variables. That's where we're starting out at. We're going to have, I believe, 4 examples today, 4 examples tomorrow, and that'll complete this set of notes. Again, this should still be a refresher for you. We're just simply talking about x, y ordered pairs. And I'm not going to read to you guys. You all are capable of reading. But when we're talking about the equations in two variables, we are talking about x and y traditionally. So even the slope-intercept form is an equation in two variables. It's y equals mx plus b. So don't be alarmed by the title. It's nothing new. It's just how we're approaching these problems right now. For the first example, it just simply says to determine if the following points are on the graph of the equation 2x minus y equals 6. So for part A, it's given us the ordered pair 2, 3. So we're going to take the 2, substitute it in for x, and we're going to take the 3 and substitute it in for y. And we're going to check, does that equal 6? So we get 2 times 2 is 4. 4 minus 3. 4 minus 3 is equal to 1, which does not equal 6. So no, these points are, or this point is not on the graph of that equation. Now if we check the second ordered pair, we do the same thing. We replace the x with 2, because that's our x value, minus negative 2, which is our y value. Does that equal 6? So we get 2 times 2 is 4. Minus and negative 2 is the same as plus 2. 6 does in fact equal 6. So yes, the ordered pair 2, negative 2 is on the graph of the equation. Example 2. We're going to graph by plotting points. We're given an equation. We want to find out some x and y values, and then we'll plot it. So the first thing we have is on the table over here on the left, we have x is negative 2. So if I put negative 2 into that equation, negative 2 times negative 2 is positive 4. 4 plus 3 is 7. So we get the ordered pair negative 2, 7. If I replace x with negative 1, I get negative 2 times negative 1 is 2. 2 plus 3 is 5. So I have the ordered pair negative 1, 5. Then if I replace x with 0, negative 2 times 0 is 0, plus 3. So now I have the ordered pair 0, 3. Replace x with 1. I get negative 2 plus 3. And then I replace x with positive 2. I get negative 4. Negative 4 plus 3 is negative 1. So you can see that as our x values increased by 1, our y values decreased by 2. So we do have a negative slope, and that's what we have in our equation. Negative 2 is the slope. We have a y-intercept of positive 3, and that corresponds to our ordered pair 0, 3. So if we plot these points, if I go negative 1, 2, 3, oh sorry, negative 1, negative 2, and then I go up to positive 7, so 2, 4, 6, 7. Then I go to negative 1 and up to 5, 0, 3, 1, 1. Did I skip? Yeah, that's right. So, sorry, the dogs are barking and going crazy. So then we can just draw our line through these points, and we have this graph. Now it's a rough sketch, so when I was labeling these, I did I think I jumped around a little bit. Let's see, negative 2, 7, negative 1, 2, 3, 4, 5. Okay, 0, 1, 2. Yeah, I put my 0, 3 in the wrong spot. That's why it was looking weird to me. Then we have 1, 1, and 2, negative 1. So that does look a lot better. And there's our graph. So still nothing new to you guys, I should hope. when we're finding intercepts, we're just simply finding where the graph crosses an x-axis and where it crosses a y-axis. It's very simple to do algebraically. Graphically, it's even easier to do because typically we can use the calculator to do that, and that's something that we'll go over in class. I would pull up an example on my calculator on the computer right now, but I didn't plan ahead well enough, I don't guess, because I didn't think about that until just then. But with this particular graph that we're given, we want to find the x-intercepts, the y-intercepts, and we want to list them as ordered pairs. So x-intercepts are anywhere a graph crosses the x-axis. So we have here, here, and here. So we have 3 x-intercepts. So in all 3 of those cases, our y value will always be 0. Anytime a graph crosses the x-axis, y will be 0. So if I count my tick marks, 1, 2, 3. So that's -3, 0. The next one is 1, 1.5. So we'll say +1.5, 0. And for the final one, we have 1, 2, 3, 4, 4.5. And since I didn't label the tick marks on the axes, you could count each one of these tick marks as 1. I was counting them as 1/2. So I won't say that there's a right or wrong way to do this one, especially since it was not labeled. The y-intercepts, there are 3 of those as well. That's wherever the graph crosses the y-axis, and in those cases the x value is always 0. So for our first one, we have 1, 2, 3, -3.5. For our second one, we have -1.5. And for our third one, 1, 2, 3. So again, looking at the graph, that's pretty easy to do. Finding the graphs or the intercepts when given an equation is equally as easy as finding the intercepts when you're given a graph, but now you're just doing a little bit of algebra and things work out just fine. Excuse me. So for example 4, we're going to find the x-intercepts and the y-intercepts of the graph of x² - 4. Yeah, you could graph this and come up with those, but we also want to make sure we understand how to do it algebraically as well. So for the x-intercepts, if you recall from the example where we did the graph, the x-intercept always occurs when y is equal to 0. So that gives us something to work with. So now if we replace y with 0, we have this equation, x² - 4 is equal to 0. We can solve that for x. We would add 4 to both sides and then take the square root of both sides. And remember, when you take the square root, you do the plus minus because you can have a positive value and a negative value, and we'll end up with ±2. So this graph has 2 x-intercepts. One of them is at -2, 0, and the other one is at +2, 0. Now let's look at the y-intercepts. The y-intercepts, if you recall, again, occur when x is equal to 0. And this is normally pretty simple to figure out. So we're going to replace x with 0 to find our y-intercepts. And when we simplify that, we just get -4. So this graph crosses the y-axis at 0, -4. So we found all 3 intercepts for this graph, the 2 x values and the 2 y values, or the 1 y value rather. And that's all you have to do. That's algebraically how you find x and y intercepts. So I hope that was pretty clear. We'll pick up with tests for symmetry in the next video for the second half of the notes, and we'll complete the other 4 examples.